Hello, I'm Datwin. This is a tutorial for Augmented Reality Part 1. The objective for the tutorial is to create a virtual environment using Scene Reconstruction. Visualize the virtual environment and use gestures to interact with the environment. Scene Reconstruction creates a virtual mesh on real-world surfaces. Interactions with the virtual mesh can simulate augmented reality. This is the final result of the tutorial. Notice how the environment is continuously scanned and updated as we move around. You can place an object on any surface because of the virtual mesh that was created. Alright, let's get started. This is main app file. We have the window group content view and also the immersive space with ID immersive. Let's go to content view file and connect it with immersive view file. At the top, create a variable to open an immersive space. As soon as the text appears in the body, we want to open the immersive space. Add an onAppear modifier to the text. Add task inside the onAppear. Inside the task, make a call to open immersive space with ID immersive. Immersive view is now linked to content view. We need to create a class that will be shared across our different views. Go to the left-hand menu and create a file called AR class. Go in the file. Import ARKit, RealityKit, Swift UI. Add main actor, observable to the class. Create a class called AR class, set as observable object. Create a var root entity to hold all future entities. Create var surface anchors that will hold a dictionary of model entities. Placing the model entities in a dictionary will allow us to better manage its creation, update, and deletion. Create let AR session. AR session is used to initialize an AR session in VisionOS. Create let scene reconstruction. Scene reconstruction will be used to access the data from the scan room. Let's go to main app and connect AR class to the different views. Create a private state variable called AR class. It will instantiate AR class. For the content view, we will add an environment modifier with AR class as an argument. Next, do the same thing for immersive view. Now we have passed an instantiated class to both views. Each view can now access the same data in the AR class. Let's go to immersive view. Access the environment and AR class instance with @environment AR class.self. Make sure to add AR class to the preview, otherwise you will get an error message. Get the root entity from AR class and add it to Reality View. After Reality View is loaded, we will check to see if the scene reconstruction is available. Add task, and inside task create a do catch statement. Make an if statement inside the do. Access the AR class and run a method call to see if scene reconstruction is possible. If the method returns true, print scene reconstruction passed, else print scene reconstruction failed. Let's go to AR class to create the check scene reconstruction method. Create a function called check scene reconstruction that returns a bool. Inside the function, return scene reconstruction provider dot is supported. Go back to immersive view. In the catch, we will print unable to start scene reconstruction with an error. If check scene reconstruction passes, we need to run the AR session. Access the AR session and run it by passing in AR class.scene reconstruction. Chain in another task to run a method called run scene construction from the AR class instance. Let's go to the AR class file to create the method. Create a function called run scene construction. Create a variable called color selection with an array of UI color. We are going to use this color in the material for the model entities. Scene reconstruction will continuously give us data in the form of updates. We need a loop to continuously query the scene construction for the data. Create a for await update in scene reconstruction.anchor updates. Save the update.anchor as let update anchor. Every time the loop runs, update can be of one of three events: added, updated, and removed. Create a switch for update events. The three cases are the three events that update gives us. The added case of the update.event means that Scene Construction is creating a new mesh for the surface that was detected. We're going to take the new mesh created and make a model entity out of it. Inside the add case, create let material and set it to simple material. We're going to randomize the color and set a transparency to 0.5. Metallic is set to false. We will generate a mesh with mesh resource and use anchor updates to get the generated mesh from Scene Reconstruction. Place a guard in case update anchor doesn't produce any mesh. Now create the model entity with mesh and material. The model entity position should be updated to where the anchor was created by the scene reconstruction. Use set transform matrix with the update anchor origin from anchor transform. Add the anchor ID and model entity to the surface anchor dictionary. Lastly, add the model to the root entity as a child. For the updated case, we need to get the model entity that was stored in the surface anchor with the updated anchor ID. Place a guard in case there's not any. Copy the model's material. Get the mesh again from update anchors. Place a guard for the mesh. Access the model component and update the mesh and material. The mesh can be different since scene construction might detect a change in the surface and create a slightly different mesh at the same location. Now update the model's position with update anchor.origin from anchor transform. The last case is removed. This case can happen when the scene construction cannot detect a previous anchor and the anchor is deleted from the scene construction. So we will remove the model entity from the root entity by getting the model entity and using .remove from parent. Lastly, remove the anchor ID from the dictionary. We need to ask Vision Pro for access to world sensing data. Go into resource file. Copy NS world sensing usage description. go into info file, add NS World Sensing Usage Description on the first line, and then add requesting world sensing as a value. Now you could hit play to see the app. As you can see, Scene Reconstruction is creating mesh for the detected surfaces, and we are making these mesh into model entities with material. You might ask why we're giving it random colors. Well, the answer is it just looks cool. You could see updates and deletion happening when you move this chair. The mesh is updated into another shape or disappear completely. Now let's interact with the surface anchor model entity with a hand gesture. Let's go to Immersive View. After Task, add a gesture modifier. We're going to add Spatial Tap Gesture. This gesture will give us 3D coordinates of the tap on an entity. We will use Targeted to Any Entity. On the end of the tap gesture, we want to get the location 3D of the tap. Store the location as let location 3D. Convert the location 3D from its local source into the scene space. Next, we will spawn a cube at the tap location with a method from AR class. Let's go into AR class to create the method. We need to make our anchor model entity interactable. Create a function called add physics input. It takes a entity, shape, and mode as parameters. Set a collision component with shape. Set input target component. Set physics body component with mode. When mode is static, it means that the physical body will not move on interaction. If the mode is dynamic, the physical body can move on interaction. Now, since our physics input takes a shape, we need to generate one in Run Scene Reconstruction. Create a guardlet shape and use shape resource that generates static mesh from update anchor to create the shape. Now with the model entity and shape, we will call add physics input to add interaction to the surface anchors. Gesture interaction will now work on the surface anchor model entity. Go down to the bottom to add a function called add cube with tap location and color as parameters. Create a mesh with generate box size 0.1. Create a material with simple material color and is metallic true. Create a model entity with the mesh and material. We want the placement location of the cube to be 0.3 higher than where we tap to prevent the cube from spawning into the surface. Use set position to place the cube at the correct location. Create the collision shape from shape resource.generate box with size 0.1. Add physics collision and input with add physics input. Use the cube entity collision shape and set model to dynamic, since the cube will interact with another object through collision. The cube can now be added to root entity. One last change to make the surface anchor entity transparent so it looks more like AR. Go to Case Added. Comment out anything with mesh or material. Create a new model entity without mesh or material. Go to Update and comment out anything with material or mesh. When there is an update to the model entity's shape, we want to update the collision with the new shape in Updated. Alright, we can use Vision Pro to test the app now. In the final video, you can place cubes in a seemingly transparent virtual environment with spatial tap. Notice how I'm placing the cube on the chair and it's able to interact with the chair's mesh collision. When I pull the chair out, the mesh is being updated and also the collision shape. Since there's no collision under the cube after the update, the cube will fall to the floor. This concludes the Augmented Reality Part 1 tutorial. Thank you for learning with me.